Hello guys, welcome you all for this end-to-end session on AIML where we're gonna learn everything that you need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot and we are learning every day. We are just learning every day and we are just learning new things every day. Okay, like both in a way of a theory and also in a coding part. So as mentioned, like in every session we have moved into a new concept called as in a form of a theory as well as coding. Now you guys are just learning the black box together with the coding way. So I hope like you guys are very enjoying. So yeah, as always, like make sure you guys have watched all the previous session videos before coming to this point, so that you guys can understand what is happening. Okay, so we have completed everything related to data. Now we have moved on to a new thing called as machine learning, where we have completed different things like linear regression, multiple linear regression, logistic regression. We have completed the decision tree, everything together with the coding part. Okay, today we will be going on to something called as random forest, a powerful ensemble technique. Guys, today it's going to be a very interesting session. Before coming for this, please watch all the session video. At least try to watch the session where we have discussed decision tree. Okay, this random forest, I will not say it builds on top of decision tree, but like it's a combination of decision tree. Okay, so yeah guys, without wasting any time, let us start this session. Okay, so what is meant by random forest? It is a kind of algorithm. Okay, so it's a powerful ensemble method in data science, combining multiple decision trees to improve the prediction accuracy and reduce the overfitting. They are widely used in various applications from regression to like classification to regression. Okay, in decision tree we will be having only one decision tree. If the depth of the decision tree increases, then there will be a high possibility of overfitting. Okay, that's the reason I'm gonna have multiple decision trees and I'm gonna club it and I'm gonna get the answer. Consider I'm gonna have a classification problem. I'm just passing a basket of fruits. Okay, I'm having a basket of fruits where I'm having the apples and banana. I'm passing an apple and I'm having 5 decision tree models. First decision tree is saying it's an apple. Second, it's saying it's an apple. Third, it is saying apple. Fourth and fifth are saying it's a banana. But actually, it is an apple. Okay. But if you choose these two models, right, last two models, you will be getting a possibility of error high. Okay. Any of that model. So in random forest, what we will be doing means we will club all the 5 things and we will get the majority voting. That means 3 models are said it is apple and 2 banana. So 3 is I, right? The majority. So we're gonna take that and we're gonna use it. This is a way of combining multiple models, that is multiple decision tree models together in order to get the result. That is called as ensemble technique. That is, if you combine multiple decision trees, then it is called as random forest. Okay, combining multiple methods or algorithms are called as ensemble. If you combine the decision trees, multiple decision trees, then it belongs to random forest. Okay, because I hope like if we combine multiple trees, then it becomes a forest, right? Like that. Okay, that is what random forest. Hope like you guys can able to understand. Yes, sir. Over to you.
Yes. So, guys, go watch all the sessions 5 to 10 times. Do reinforce learning, absorb the information, digest the information, and apply. Do all the assignments and subscribe to our channels. Also, press the bell icon so that you will get notification for each session on time. So, yeah, give us feedback for each session, guys, in the comment section so that we can continuously improve our sessions. So, random forests, it is a powerful ensemble techniques. Like you call it ensemble technique or you call it ensemble learning. Ensemble means you use different models, okay, multiple models to train, and you use different techniques, you can say, to optimize and make your make your model performance better. Okay, so random forests are powerful ensemble learning methods, okay, in data science, which combines multiple decision trees to improve prediction. Okay, so you will use multiple decision trees, okay, multiple ways, okay, and accuracy and reduces the overfitting. Okay, they are widely used in various applications from classification to regression problems. So ensemble techniques, you can, so you ensemble different models, different decision trees, to improve the prediction of accuracy and reduce the overfitting. Okay, so we use in classification and regression problems. So these are the features, the basic surface level feature, and we'll go to a meta level where we'll understand how ensemble techniques work in random forest. Or okay, so this is what it is. So just focus on what and why. So how will naturally come and when we go and apply. Okay, but just have a focus on what and why. So have a long-term objective function. Keep learning for a lifelong learning. Build a vision for your learning, guys, not for salary and job. Build a vision for your learning so that you will be always successful, always in demand. Okay, so continuously improve your skills. So keep learning deeply. Thanks. Let's move to the other section.
Yeah, sure, sir. Guys, moving on. Okay, now in this also we are having gonna have a understanding of decision tree. Okay, I hope you guys already know. Okay, guys, just ping in the comments what is decision tree. Okay, we have a root node. We will split it into number of branches, sub branches, and then we gonna have a leaf nodes, right? Let's understand the decision tree, because like I have said, right, combination of decision tree is the random forest. Let's understand decision tree, because previous session only we have completed decision tree. Let's see. Tree structure. A decision tree works by recursively partitioning the data based on the features, creating a tree-like structure. Hope you guys have understand. Okay, we're gonna have a data based on a condition. We're gonna split it in a form of a tree. Okay, then decision node. Each internal node represent a feature and a split condition guiding the decision path. Okay, whenever you have a tree from a root, it's gonna just split the things and it's gonna have the branches. Okay, the inside branches are called as a decision nodes, which is based on the conditions that we have applied. Leaf node represent the final prediction or classification for each of the data point. Okay, we come for the root where everything is there. Based on the condition, we need to create a branches, that is decision nodes, sub branches, sub decision nodes. Finally, we will be ending up with the leaves where the result lies, whether it will be a classification result or it will be a regression result. That's it. Okay, root, branches, sub branches, leaves. Okay, input, and the final layer is output, inside which it's based on the decision roots that we are providing. Okay, I hope like it's a simple explanation. Okay, so yeah, sir, over to you.
Okay, so understanding decision trees, guys. There are three steps to understand decision trees. So, first is decision structure. There is whatever you create in life, guys, whatever model, whatever, there is always a structure. So, everything starts with a structure, which is architect. That's what is structure. Even our body has a structure. Then there are, you will see detailed organs, right? Detailed connection with different organs. If you observe even yourself, so you'll find a lot of things. Okay, what you can relate. So first is structure, same like tree structure. So in this decision trees, we have a structure that works recursively. Okay, partitioning the database on features, creating tree-like structure. So it is tree-like structure, like roots. You have branches, you have leaves, you have, okay, so different nodes and stuff. So the same. Okay, so second is decision nodes. Each internal node represents a feature. So see, in trees, it's a different this thing. But if you see from the architectural architect of the decision trees is from trees, but the definition for each thing is different. That is as per like node. What is node? Each node represents feature and splitting and split condition guiding decision path. Okay, this behavior you won't see in tree, but architect you can take it from tree, that we have taken the structure from tree. Okay, but here it is a decision node, and which is like each node represents feature and splitting condition guiding the decision path. Okay, then leaf nodes. Leaf nodes are represent the final prediction of classification for each data point. So that is what it is. So architect we have taken from trees, but each function or each node or each representation has its specific definition and role in decision trees. Okay, so this is all about understanding the decision trees. Let's move to the other section.
Yeah, sure, sir. Yeah, moving on, let's discuss this ensemble learning techniques. Okay, we are having three different things, and N we are having random forest, right? We are having two different types of ensemble technique. One is bagging, another one is boosting. What is meant by bagging? Bagging aggregating involves creating multiple subsets of data with replacement, training separate models on each of the subset. Okay, consider how a bagging works. Okay, we will be having a data set. Consider we are having a 100 records, or we consider having 90 records. We just split into 30, 30, 30, and we will be having three different models, and we are training, and we are using the prediction. This is called as bagging. Splitting the data, train the model separately, called as bagging. Next, there is another technique in ensemble learning, that is boosting. Boosting sequential trains models gains more weightage to misclassified instance, improving overall accuracy. Okay, then what is boosting? We are having 90 data. We feed that 90 data to a first model. Its accuracy is 30%. We're gonna use this model together with the data to train the misclassified values of the first model to the second model. Now the next accuracy will be 60%. Then I'm gonna use the error that is given by the second model, and I'm gonna use the data set and train for the third model. Now the accuracy will be increased. So you guys can see there is a sequence of training. We give the input, first model will train, and based on the output that it gets and the error, the second model gonna learn from it, and based on the output or result of the second model, the third model gonna learn from its error of the second model. Like that, there will be a sequence of steps. In bagging, everything is separate. Train separately, use separately, everything separate. Boosting, it is a sequential thing. Okay. Now comes random forest. Random forest is a bagging. Combines bagging with the random feature selection at each node, reducing correlation between trees and improving its generalization. That's okay. So we will be having individual decision trees, and we will get the result of them, and we will combine it based on the majority voting, or majority voting for classification, and averaging for regression. That's it. Random forest is a bagging technique. It does everything separately. Boosting is completely different. It is a sequential technique. Okay. Hope you guys can understand. Just remember, we are having two kinds of ensemble technique. One is bagging, another one is boosting. Bagging is the separate algorithm, separation algorithm. Boosting is something like a sequential algorithm. That's it. Random forest belongs to the separation algorithm, that is bagging algorithm. Okay. Hope you guys can understand. Yes, sir. Over to you.
Yes. So ensemble learning techniques. Bagging is a bootstrap aggregating involves creating multiple subsets of data. That is what it is, and that represents training separate and okay separate models on each subset. So this is what is bagging. Bagging is it involves creating multiple subsets of the data. That is the first aspect, and with replacement and training separate models on each subset. So that is what is the that is what is differentiator, and that is the feature of ensemble learning technique, guys. So boosting is when boosting is uh, sequentially trains models, gives more weight to misclassified instances, okay, which are not classified, and improves overall accuracy, because when it will give weight to misclassified instances, so then it will definitely improve. That is where boosting is used. Okay, random forests are, it combines bagging and boosting. Okay, features selection at each node, reducing correlation between trees and improving generalization. That is why, random forest is a very powerful technique, but it also has its limitations, guys. Okay, so you have to understand the limits of each model and each technique. So this is what is all about ensemble learning techniques. So we'll go to the other section.
Yeah, sure, sir. So moving on, let's see what we are having. Okay, feature importance in random forest. Okay, let's see, because like random forest, as we are mentioning, we're gonna train multiple models. Okay, we need to just use only important features in the models. Okay, then only the training time will be reduced. Okay, otherwise it will be very high. Okay, so random forest offer a unique capability to access the relative importance of each feature in predicting the target value. Okay, whenever you are having a data set, consider our disease prediction data sets, we are having features. Okay, and we need to consider which of the features are important to predict the target, that is a person has the heart disease or not. Okay, so this has a unique thing to do it. This insight is invaluable for understanding the underlying relationship in your data, making his informed decision about model building and feature selection. Let's see. Feature importance score. It is what qualify the contribution of each features to the model's prediction power. Higher score represent it as a more influence feature. Simple. Just put feature importance. 10 features in like heart disease prediction dataset. What are the features? How much they are important? Based on this feature importance score. Okay, whenever the score is high, it has that much impact onto the target. That's it. Okay, understanding feature importance empowers you to focus on the most relevant features or predictions, potentially simplify your model and improves its interoperability. It enables you to identify and prioritize features that derive the model's outcome, leading to more effective decision making. Okay, consider we are having 1,000 features. If you apply this random forest, it's gonna boil down to the features important scores. So you guys can take the feature which has the important scores more than 20% or 30% or 50%, and now the model's features will be reduced. Then the training time will be reduced, the model complexity will be reduced, and the inference time for the result also reduced. Like this. Okay. This feature important score, which is provided by this random forest model, is very, very, very important. Okay. I will say it's a unique thing which is not possible in other models. Okay, this is what all about the feature importance in random forest. Yes, sir, over to you.
So, guys, feature importance is very, very critical. So, in random forest, specifically when we talk about feature importance in random forest, that is very specific. Random forest offers a unique capability to assess the relative information importance of the each feature in the predicting the target variable. That is the it assesses the relative importance, okay, of the each feature in predicting target variable. So so the main thing is that it predicts the target variable relative importance, okay, for each. So then this insight is invaluable of understanding underlying relationship in your data, making informed decision, because that capability is very, 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 very important, guys. Okay, so each feature in predicting the target variable, okay, relative importance, that is then this will help understanding the underlying relationship in your data and making informed decision which is based on the data. It is not hypothetical or imaginary, but and building a model and feature selection about the and decision making and about the model building and feature selection. Then the feature important, then there is another importance is feature importance score, okay, quantifies the contribution of each feature to the model's predictive power. That is another feature, and a higher score indicates a more influential feature. Okay, then we have the understanding of feature importance empowers you to focus on most relevant predictors, potentially simplifying your model. Okay, when you understand the features importance, that will empower you to you have to focus on most relevant predictors, because you will not, if you see in feature engineering also, when we have learned in previously, we focus on only the features which are relevant for that model and which will help us to predict in the model, and performance will be improved. We are not focusing on all the features, right? As per the objective, like whatever problem we are solving, we need to focus on those things only, right? If so, I'll give example. If somebody has cancer in head, so what we'll do is, first of all, we'll do checkup, that entire body checkup, suppose, and then after that we know the cancer is in the head, so there is no need to do surgery in the arm, right? So similarly, features give us the insights and understanding that where to focus, and then model will improve according to the your problem statement and the objective function of your project, right? So there is no need to go for irrelevant features. Okay, that performance of your model will decrease. Okay, that is the main idea. So, yeah, potentially simplifying your model, of course, when you focus on the specific what is required, then it is simple, and that will improve your performance and improves the interpretability. The model will interpret properly, and enables to identify prioritizing features driven that drive the model's outcome. That is what, see, ultimately you're building a model for the problem statement, guys. What problem you're solving. So you need to focus on the features which are helping you to build that model. That is what the main idea is, and leads to more effective decision making. That is what we are building this model for. So this will help you when you understand features importance in random forest, and this will apply to other models also, if we try to generalize it. Okay, here we are specifically talking about random forest, but if you use this idea for other models as a generalization, uh, feature importance is very crucial, guys, in the model. That is what the inference is coming out of this particular knowledge representation. So let's move to the other section.
Yeah, sure, sir. So yeah, guys, I think we have discussed things that we required for this session. Okay, we have introduced you random forest, how it is related to decision tree, how we have built at this, or what are the important features that we are having in random forest, what random forest belongs to, whether it is a bagging or boosting, like that we have seen. We will pass here. We will continue this theoretical session in the next class or next session. So until then, guys, keep learning, keep learning. If you guys have any doubts, say stuck anywhere, just ping in the comment section. We will take up and we will solve your doubts. Okay. So guys, keep learning, and we will all meet in the next session. Until then, bye guys. Take care. Bye.
Bye, guys. Take care. Keep learning. Watch all the sessions 5 to 10 times. Do reinforce learning. Absorb the information, digest the information, apply the information, and have a long-term objective function. Become a lifelong learner. Keep learning deeply and give us feedback. And if you have any questions, write in the comment section, and keep giving us feedback for improving all these sessions. Keep learning deeply. And if you have not subscribed, subscribe to our channel, and also press the bell icon so that you will get notification for each session. Keep learning deeply, build a lifelong learning attitude, and build a vision for learning, guys. That will help you to become world's best data scientist, or AIML engineer, or AIML researcher. Thanks.